6 raised to the power e raised to the power minus 6 into 6 raised to the power 1 divided by 1 factorial. Your 0 factorial is 1, and any number with power of 0 is 1. That means you are going to get e raised to the power minus 6 plus e raised to the power minus 6 into 6. We will be taking e raised to the power minus 6 as common, so it will be within brackets 1 plus 6, that will be equal to 7, and we know that the value of e raised to the power minus 6 is 0.00247. Multiplying these two, we are going to get the probability of getting defective bulb less than 2 from a sample of 200 units. Now, moving further, that is unit 7, which consists of continuous probability distribution. What we are going to study in this variable of interest, we take any value within a given range. This type of random variable, which can take an infinite number of values, is called a continuous random variable. Thirdly, probability distribution of such a variable is called a continuous probability distribution. We will be starting with the most important topic, which will be of great importance in your this MMPC5 as well as in your MMPC50. That is normal distribution. If you remember, in normal distribution, mean, mode, and median, all the three values are equal, and we have a bell-shaped graph of it. Normal distribution is the most versatile of all the continuous probability distributions. It is found useful in statistical inferences, characterizing uncertainties, many real-life processes, and approximating other probability distribution. Now the question is, what is normal distribution in statistics? A normal distribution is a continuous probability distribution that is symmetrical around its mean. Most of the observations cluster around the central peak, and the probabilities of value further away from the mean taper off equally in both directions. That is why it is a bell-shaped curve. What are the properties of normal distribution? We have the probability distribution function of normal distribution is given by fx equal to 1 upon sigma under root 2 pi into e raised to the power minus 1 by 2 within brackets x minus mu upon sigma whole square. You have to remember x minus mu upon sigma, which will be equal to z when we will be calculating numericals related to normal distribution. Now the question arises, where this normal distribution is actually applied. Birth weight of babies, height of males, blood pressure in your medical analysis. What are the properties of this normal distribution? In a normal distribution, mean, mode, median, all three are equal. The total area under the curve should be equal to 1. Normal distributed curve should be symmetric at the center, and there should be exactly half of the values are on the right side of the center and exactly half of the values on the left side of the center. That means we can say that in between we have a center line, and on the left side we have a probability of the event as 0.5, and on the right side or on the other side we have a probability of 0.5, the occurrence of the event. What is meant by area under normal curve? When we plot of fx versus x given in the normal curve, and the area under the curve gives us the probability. The normal distribution is symmetric about the mean, therefore area on each side of the mean is 0.5. The empirical rule states that 99.7% of the data observed following a normal distribution lies within 3 standard deviations of mean. And under this rule, 68% of the data falls within 1 standard deviation, 95% of the data within 2 standard deviations, and 99.7% within 3 standard deviations from the mean. The formula for calculating z-squared, that is, z is equal to x minus mu upon sigma, where x is the raw score, mu is the population mean, and sigma is the population standard deviation. All these 3 values will be given to you in the problem. As the formula shows, the z-square is simply the raw score minus the population mean divided by the population standard deviation. That is, z equal to x minus mu upon sigma. Normal distribution describes continuous data which have a symmetric distribution with a characteristic bell shape. Binomial distribution describes the distribution of binary data from a finite sample. This is basically a bell-shaped normal curve. Now, we will be going back how to apply this normal distribution in practical problems. A radar unit is used to measure speeds of car on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour and standard deviation of 10 kilometers per hour. What is the probability that the car picked at random is traveling at more than 100 kilometers per hour? Here, the problem is related to speed of the car. The information what is given to us in the problem is the mean is 90 kilometers per hour. That means mu is 90 kilometers per hour. Standard deviation, that is sigma, it is 10 kilometers per hour. Now what we are supposed to calculate? We are supposed to find out the probability of picking up a car which is traveling at a speed of 100 kilometers or more. That means it is sure that the speed, the car what we are selecting is running at more than 100 kilometers per hour. That means x is greater than 100 kilometers. Z will be equal to x minus mu upon sigma, that is 100 minus 90 divided by 10, which comes out to be 1. We have to calculate the value of probability z equal to greater than 1. That is, as we are aware of that on one side we are getting a value of z equal to 1, and that means it is a positive number, therefore it will be on the right side. More than 1. The total area of right side is 0.5. And we have the value of z equal to 1, which will be given to us in the problem. That is 0.8413. When we are going to subtract it from 1 minus 0.8413, this comes out to be 0.1587. What are the characteristics of standard normal distribution? A z-score of a standard normal distribution is a standard score that indicates how many standard deviations are away from the mean and individual value x lies. When z-score is positive, that means x value is greater than mean. When z-score is negative, the x value is less than mean. And when z-score is equal to 0, that means the x value is equal to the mean. This z-score tells us how many standard deviations are away from the mean each value lies. This is basically the standard normal distribution. We can see that at the center we have 0, and on the right side the values are increasing from 1 to 3, and on the left side we have -1, -2, -3. We have to remember the one thing, that this graph never meets x-axis. It is always away from the base. 50% the probability is on the left side and 50% is on the right side. Usually happening in real world follows a normal distribution. This enables researchers to practice normal distribution as a model for evaluating probabilities linked with real world scenarios. Basically, the analysis includes two steps: converting raw data in the form of z-score, using the conversion equation, which we know that z is equal to x minus mu upon sigma. And secondly, finding the probability after the raw data is transformed into z-score. Then, with the help of standard normal distribution tables or normal distribution calculators available online, to find probabilities linked with the z-score. Finding the probability after the raw data is transformed into z-score, then with the help of standard normal distribution table or normal distribution calculator available online, to find the probabilities linked with the z-score. We will take up an example to understand it, how this is performed. For some computers, the time period between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. Achal has one of these computers and need to know the probability that the time period will be between 50 and 70 hours. Here, mean is 50, standard deviation is 15, and we are given two values of x. That means 50 and 70. And we have to calculate the probability between 50 and 70 hours. We have x. Let x be the random variable that represents the time period. We know mean is 50, that is mu is equal to 50. Standard deviation, sigma is equal to 50. And we have to find out the probability that x lies between 50 and 70. That means mathematically it will be written as probability 50 less than x less than 70. Now, we will be transforming this 50 and 70 into z form. When x is equal to 50, your z will be 50 minus 50 upon 15, that is 0. And when x is equal to 70, it will be 70 minus 50 divided by 50, which comes out to be 1.33. Now, we will plot this on z graph. Converting p 50 less than x less than 72 in terms of z, so it will be p 0 less than z less than 1.33. That means which will be equal to the area on the left of z is equal to 1.33 minus area to the left of z is equal to 0. From the table, we will get the value of z is equal to 1.33, which is 0.908 minus 0.5, which comes out to be 0.4082. That means the probability that Achal's computer has a time period between 50 and 70 hours is 0.408. We'll take another example, which is related to, again, normal distribution. Most graduate schools of business require applicants for admissions to take Graduate Management Admission Council GMAT examination. Scores on the GMAT are roughly normally distributed with a mean of 527 and standard deviation of 112. Now, what is the probability of an individual scoring above 500 on the GMAT? We have mu equal to 527, sigma equal to 112, and x equal to 500. Putting up the values, first of all, we will calculate z value. Z value will be z equal to 500 minus 527 upon 112, which comes out to be negative 0.24107. That means it will be on the left side. We have to calculate the probability that x is greater than 500 because individual scoring above 500. Converting it to z, z will be probability z greater than negative 0.24. Value of z equal to negative 0.24 will be given in the problem, or we can take it from the table or from the computer online. That we get 0.4052. We will be subtracting it from 1. 1 minus 0.4052 is equal to 0.5948. What we have calculated here can be seen on the graph also. 527 is taken at 0 because that is the mean value. We were supposed to calculate individual scoring above 500, marking it on 500, it is on the negative side. The area will be all towards the right. Complete area minus, complete is 1 minus the value of z equal to 0.405. That means 1 minus 0.4052 is 0.5948. We'll take another example. The average number of acres burned by forest and range fires in a large New Mexico country is 4,300 acres per year, with a standard deviation of 750 acres. The distribution of number of acres burned is normal. What is the probability that between 2,500 and 4,200 acres will be burned in any given year? The problem is related to normal. It is already explained in the problem. We have mean, we have standard deviation, and two values of x. We have to calculate the probability as 2,500 less than x less than 4,200. We will be converting these x in terms of z. Z is equal to x minus mu upon sigma. In first case, when x is equal to 2,500, your z will be negative 2.40. And when your z is 4,200, your z will be negative 0.13. Going back to the graph, when we will be plotting it on the graph, we will be converting this b 2,500 less than x less than 4,200 in terms of z. So that comes out to be probability negative 2.40 less than x, z less than 0.13. We will get this value of z from the table, and we can place it in as 0.4483 minus 0.008, which comes out to be 0.4401. Now what we have understood or what we have calculated, exponential distribution is found to be useful for characterizing uncertainty in machine life, length of telephone calls, etc. And normal distribution is found to be useful for characterizing dimensions of machine parts, heights, weights, etc. Now we move to Unit 8, that is decision theory. A necessary condition for the existence of a decision problem is the presence of alternate way of action. Each action leads to a consequence through a possible set of outcomes, the information on which might be known or unknown. One of the several ways of classifying decision problems have been based on this knowledge about the information on outcomes. How this is classified, or what is the classification? Decision making under certainty. The information on outcomes are deterministic and are known with certainty, and decision making under uncertainty, that is decision, so that which you have to take a decision like that, and the information on outcomes are probabilistic, with the probabilities known or unknown. Depending on the planning horizon under consideration, as also the nature of decision, we have either a single stage decision problem or a sequential decision problem. Marginal analysis and decision theory approach. Marginal analysis for solving such single stage problems. For sequential decision problems, the decision tree approach will be used. In both the marginal analysis and the decision tree approach, we will be using the expected profit as the criteria of our decision. Expected monetary value, that is EMV. This does not take into account the decision maker's attitude towards risk. As far as your preference theory, this provides us with the remedy in this context by enabling us to incorporate risk in the same setup. The other problem with expected monetary value is that it can be applied only when the probabilities of outcomes are known. For problems where the probabilities are unknown, one way out is to assign equal probabilities of the outcome, and then we use EMV for decision making. However, this is not always rational, as we will find other criteria which are available for deciding on such situations. Marginal analysis. This is a technique which is widely used in business decision making and ties together much of economic thought. In any situation, people want to maximize their net benefits or profits. Net benefit is equal to total benefit minus total cost. Then comes the control variable. To do marginal analysis, we can change our variables, such as quantity of a good you buy, the quantity of output you produce, or the quantity of input you use. This variable is called the control variable, and marginal analysis focuses upon whether the control variable should be increased by 1 unit or not. That is decision-making process. What are the key procedures for using marginal analysis? First of all, we have to identify the control variable, that is CV. Then comes, we have to determine whether what the increase in total benefit would be if 1 more unit of the control variable were added. This is marginal benefit of the added unit. Third, determine what the increase in total cost would be if 1 more unit of control variables were added. This is marginal cost of the added unit. And if the unit's marginal benefit exceeds or equal its marginal cost, it should be added. What is the procedure what we follow for using marginal analysis? Remember, you look at the changes in the total benefits and total cost. If a particular cost or benefit does not change, ignore it. Why does this work? Because marginal benefit is equal to increase in total benefit per unit of control variable. That is, mathematically, MR is equal to delta TR upon delta Q CV. CV is control variable. Marginal cost is equal to increase in cost per unit of control variable. That is, MC is equal to delta TC upon delta QCV. What is change in net benefit? Which is mathematically marginal benefit minus marginal cost. Why does this work? When marginal benefit exceeds marginal cost, net benefits goes up. And if the marginal unit of the control variable should be added in that case. Now the thing is that how the problem is formulated. A decision problem is characterized by decision alternatives, states of nature, and resulting payoffs. The decision alternatives are the different possible strategies the decision maker can employ. And the state of nature refers to future events not under the control of decision maker, which may occur. That is, state of nature should be defined so that they are mutually exclusive and collectively exhaustive. Influence diagram. This is a graphical device showing the relationship amongst the decision, the chance of event, and the consequences. We use different nodes, that is square or rectangles which depict decision nodes, circle or ovals which depict chance node, diamond depicts consequences nodes, and lines or arcs connecting the nodes shows the direction of the influence. Then comes payoff tables. The consequence resulting from a specific combination of decision alternatives and a state of nature is a payoff. A table showing payoffs of all combinations of decision alternatives and the states of nature is a payoff table. This payoff can be expressed in terms of profit, cost, time, distance, or any other appropriate measure what we are considering in the problem. Decision phase. A decision tree is a chronological representation of decision problem. Each decision tree has two types of nodes, that is round nodes, which corresponds to the state of nature, while square nodes corresponds to the decision alternatives. The branches leaving each round node represents the different state of nature, while the branches leaving each square node represents the different decision alternatives. At the end of each limb of the tree are the payoffs attained from the series of branches making up that limb. If we consider probabilities in decision making, first of all, the condition arises decision making without probabilities. Three commonly used criteria for decision making when probability information regarding the likelihood of the state of nature is unavailable. That is the optimistic approach. Second one is conservative approach. And the third one is minimax regret approach. The optimistic approach would be used by an optimistic decision maker. The decision with the largest possible payoff is chosen. If the payoff table was in terms of cost, the decision with the lowest cost would be chosen. Conservative approach. The conservative approach would be used by a conservative decision maker. For each decision, the minimum payoff is listed and then the decision corresponding to the maximum of these minimum payoff is selected. Hence, the minimum possible payoff is maximized. Now, we move to block 3, that is sampling and sampling distribution, which consists of 4 units: sampling method, sampling distribution, testing of hypothesis, and cheese practice. We will be starting with sampling methods. Right. One is interested in measuring some attributes of a large or infinite group of elements by studying only a part of it. Which we will be taking a sample from it. This process of inferring something about a large group of elements by studying only a part of it is referred to as sampling. Suppose here the example is of Bank of India. We try to measure the level of employee motivation. The administrators are questioning 250 employees from different branches and offices all over the country out of its 30,000 employees. What are the different definitions that we will be using in this sampling method? First of all is population. Population is a collection of all the elements about which some inferences is to be made. Any characteristic of a population will be referred to as a parameter of the population. Some population parameters is inferred by studying only a part of the population, that is sample. And any characteristic of a sample is called statistics. Now, with this figure, we can see that there is a yellow rectangle, and in between we have an oval. Parameter what we consider is the motivation level of the population. The population is 30,000 employees. Required is the sample of 250 employees from all these 30,000 employees all over the country. And your statistic is motivation level of the sample. And your Celsius is or the complete enumeration. This whole triangle is the Celsius or complete enumeration of the population. Now, what are the different characteristic symbols what we will be using when the problem will be given to us? If we talk in terms of population, that means it will be a parameter. Population size will be denoted by n. Population mean by mu. Population standard deviation by sigma. And population proportion by capital P, what we have studied. Now, moving further, in case of sample, we will be using statistic. Sample size will be given by small n. Your sample mean will be given by x bar. Your sample standard deviation will be given by s, and your sample proportion by p. Now, what is the need of sampling? The time taken for the study, cost involved for the study, physical impossibility of complete enumeration, practical infeasibility of complete enumeration, enough reliability of inferences based on sampling, and quality of data collected. What are the different types of sampling? There are two basic types of sampling depending on who or what is allowed to cover the selection of the sample. First one is probability sampling. Each element in the population has some non-zero probability of getting included in the sample. The second one is non-probability sampling. Here, samples may be picked up based on the judgment or convenience of the enumerator. What are the methods of probability sampling? First one is simple random sampling. Second one is systematic sampling. Third one is stratified sampling. The fourth one is cluster sampling. Simple random sampling. Under simple random sampling, each element of the population has an equal probability of getting included in the sample. All other forms of probability sampling use this basic concept of simple random sampling, but applied to a part of the population at the time and not to the whole of the population. You are aware of what is meant by probability, because here we will be considering different conditions. So we will be using two different n's, capital N and small n. Under simple random sampling, which ensures that any of these samples has the same probability of being picked up, is given by 1 upon NC. We'll see in the problem how this is applied. Then comes your systematic sampling. Systematic sampling proceeds by picking up one element after a fixed interval depending upon the sampling rate. For example, for a sample of 10 from a population of size 100, our sampling ratio will be 10 by 100. That means 1 by 10. That means deciding where to start from among the first 10 names in our field. If this number happens to be 7, for the example, then the sample would contain members having serial number 7, 17, 27 till 97 in the field. Stratified sampling. The basic idea behind the stratified sampling is to divide the whole heterogeneous population into smaller groups or subpopulations, such that the sampling units are homogeneous with respect to the characteristic under the study with the subpopulation, and heterogeneous with respect to the characteristics under the study between or among the subpopulations. These subpopulations are termed as strata. Treat each subpopulation as a separate population and draw a sample by SRS from each strata. Then strata. Stratified random sampling is a method of sampling which involves dividing the population into smaller groups, which is known as strata. The group or stratas are organized based on the shared characteristics or attributes of the member of the groups. And this process of classifying the population into groups is called stratification. Now we will see how this mathematically what we have discussed comes into application. We have stratum number 1, 2, 3. Number of elements or your sampling elements in this stratum are 200, 300, 500, total is 1000. We are taking up a sample size of 10 from the first stratum and 15 from the second and 25 from the third. Sampling ratio comes out to be 10 by 200, that is 1 by 20, 15 by 300, that is again 1 by 20, and 25 by 500, again 1 by 20. And if from the last row we say that is 50 by 1000, again 1 by 20. That means this is a proportional, practical example of proportional stratified sampling. Mathematically, graphically, and in terms of your formula. This proportional stratified sampling, if the different strata in the population have unequal variances of the characteristics being measured, then the sample size allocation decision should consider the variance as well. It would be logical to have a smaller sample from a stratum where the variance is smaller than from the other stratum where the variance is higher. Here we can say if sigma 1 square, sigma 2 square, sigma 3 are the variance of the p strata respectively, then the statistical efficiency is the highest when upon n1 sigma 1 is equal to all the three. We will see we have stratum number 1, 2, 3. Number of elements in the stratum is 200, 500, total is 1000. Variance 2.25, 4, 0.25, and your stratum standard deviation is 1.5, 2, 0.5. Your sample size 13, 26, 15. And your sampling ratios, here sampling ratios are different. 0.065, 0.087, and 0.022. Then comes your cluster sampling. We take up an example of a colony which is divided into 11 blocks from block A to block A. Cluster sampling is used in this situation by treating each block as a cluster. 2 blocks are selected out of 11 blocks at random, and the information is collected from all the families residing in those 2 blocks. And the information what we gather from these 2 blocks can be considered applicable to all other 9 blocks also. Now, what is the difference between cluster versus spreader? Spreader are homogeneous within and different from other strata, whereas your clusters will be heterogeneous within and the different clusters should be similar to each other. A cluster is a mini population and has all the features of the population. The criteria used for stratification is a variable associated with the characteristics measured. Here, the convenience of data collection is usually the basis for cluster definition. There are very few strata, but there are many clusters. Multi-stage and multi-phase sampling. Multi-stage sampling is that where the sampling unit is something larger than the individual element of the population in all stages, but giving the final one. But in case of multi-phase sampling, this is designed to make use of the information collected in one phase to develop a sampling design in a subsequent phase. A study with 2 phases is often called double sampling. Convenience sampling. In this type of non-probability sampling, the choice of the sample is left completely to the convenience of the interviewer. The cost involved in picking up the sample is minimum, and the cost of data collection is also generally low. For example, the interviewer can do some retail shops and interview some shoppers while studying the demand for non-irritated beverages. Purposive sampling. In convenient sampling, any number of population can be included in the sample without any restriction. But when some restrictions are put on the possible inclusion of a member in the sample, the sampling is called purposive. That means we are doing sampling for a particular purpose, to study the conditions. Then comes your judgment sampling. In judgment sampling, the judgment or opinion of some experts forms the basis for sample selection. The experts are persons who are believed to have information on the population which can help in giving us better samples. Such sample is very useful when we want to study rare events or when members have extreme positions or even when the objective of the study is to collect a wide cross-section of views from one extreme to the other. Quota sampling. Even when we are using non-probability sampling, we might want our sample to be representative of the population in some defined way. This is sought to be achieved in quota sampling so that the bias introduced by sampling could be reduced. Example, a family size could be either another criteria, and we want to set quotas of family, which family size up to 3, between 4 and 5, and above 5. However, if the number of such criteria is large, it becomes difficult to locate sample members satisfying the combination of the criteria. Now comes how to determine what is meant by sample size. One of the most important factors that affect the sample size is the extent of variability in the population. Taking an extreme case, if there is no variability, that is, if all the members of the population are exactly identical, a sample of size 1 is as good as a sample of 100 or any other number. A second consideration in the confidence is the inference made. The larger the sample size, higher is the confidence. And in many situations, the confidence level is used on the basis to decide sample size. With this, we will be concluding this session.